Hi everyone, my name is Thomas Kim. Today is July 25th, 2019. This is 19th episode about graph in C++. In this episode, we will learn about C++ container classes for any object of any type. In our previous episode, episode 18, we learned std beast and std variant. If you haven't watched my previous episode, please double click this link to watch my previous episode, episode 18. In episode 7, we learned about type list, std variant, and container of variance. If you haven't watched episode 7, please double click this link and watch this video. Also in episode 8, we learned about std tuple and containers of tuple. C++ 11 standard introduced std tuple, and C++ 17 standard introduced std variant. By combining std tuple, std variant, and C++ container classes, we can create container classes that can hold any object of any type. If you have watched my previous videos up to this point, you can understand what I am doing in this episode. Especially if you haven't watched my previous videos about episode 8, episode 7, episode 18, please click these links and watch them. Without further ado, let's get started. Start Visual Studio Code. On the CPP extension graph subfolder, click this button, 19, containers.cpp, hit enter. In the include folder, talk-play-fun types.hpp. In this file, Ctrl F, container of variant class. This class defines container of variance. As specialization, there is container vector of variance, deque of variance, list of variance, and set of variance. Other kind of container variance, you can define them using container of variance. Also, container of tuple defines vector of tuples, deque of tuples, and list of tuples, set of tuples. Other kind of container type, you can combine them together and create any kind of container class that can hold any elements of any object. The only limitation is your imagination. I will close this file, include talk-play-fun output hpp, talk-play-fun ss stream, auto, endl, talk-play-fun, endl, void test container of variance, int main. I will copy this function name and paste it here. I will define coin t int using money t double using title t constant character pointer using back t I will define a namespace alias here. Name space types talk play fun types vector of variant coin T money T title T. So I defined my back type vector of variance that can hold a coin, money, title using item T. Back T has variant type because this is vector of variance. Back T, my back, this is vector of variance. My back, in place back, I have 10 coins. My back, in place back, I have 123 cents. My back, in place back, I have a title, Modern C++ Programming, and I can put another item in place back. I have another book title, C++ 17 Standard. We can put any elements that has type int, double, or character pointer. Now we can display all items, stream, contents of my bag. Now we will build start command prompt G++ std C++ 17 19 containers.cpp, hit enter. CLS, so contents of my bag, 10 coins, $100, 23 cents, and two titles. One is Modern C++ Programming, another is C++ Standard. Now we can process element by element like this. Auto handle coin T value stream draw value I say count coin count coins. I will define another one, auto NL talk play fun NL. Don't forget semicolon here. Auto handle money T money. Don't forget semicolon here. Stream I have a money box. NL auto handle title T title. I like reading title NL. Don't forget semicolon here. Types overloads we define handle my bag. I copy coin, I copy my money, I copy my handle title, or handle items. I copy this and capture as reference, or it can be variant, or you can say item. Okay, item, std, beast, handle, my bag, item. Don't forget semicolon here. Then for auto, item, my bag, handle, items, item, stream, and stream, items in my bag, item by item. And now we can compile and run CLS A. So items in my bag, item by item. There are 10 coins. I have 100 bucks, and I like reading modern C++ programming. I like reading C++ 17 standard. So we can handle item by item. I will add one more here, and L, and L. If you want to try using Clang compiler, I have to start this command prompt, clang std C++ 17 x clang app lto visibility public std 19 containers.cpp, hit enter. CLS. Now I'm using Clang compiler. So Clang compiler also handles items by item successfully. Before we further proceed, I would like to remind you one thing. Please note that when we create lambda closure for processing, we used by value semantic. For optimization purpose, we can use reference like this too. Okay? In some case, using reference can be more efficient. In case of title, we can use reference semantic too, like this. Also here, instead of doing this, I would recommend you to use auto reference. Then I will put this out of the block like this. I fixed like this for optimization purpose. We can compile, and again CLS, it runs successfully as before, but it is more efficient. I found this programming is very typical, so I will copy it for more simplified version. I pasted once again here, test container of variance simplified. Okay, I will copy this function name and paste it here. I will disable it. everything is the same, but this part is used repeatedly, so we don't need to define like this. I simply removed that, and I defined overload. If you go to definition, it defines a handle function like this, so you can use it like this. Instead of doing this, we can define a back type, then handle. Okay, it's much simpler because we don't need to define unnecessary lambda capture here. Also, if you want to, we can simply copy it, cut, and paste it here. This is one lambda. It can be a little bit confusing like this. In second case, we don't need it now. I will cut here up to this point, cut, then paste it here. For second case, it should be semicolon, and also we can cut like this. Okay, then now we provide like this from my back. We don't need this, I deleted, and we don't need this like this. Okay, we defined 3 lambda as member. Don't get confused like this. This is constructor. Then here we can call, we defined this my back, and we use the handle like this. So if we build once again, it should work successfully as before. Okay, in some case it can be simpler because we can define lambda capture as member. Constructor, this is constructor actually. Constructor over types over rows. Okay, then we use this instance like this using handle item. Okay, but I found this pattern. My bag is container vector over variance. This pattern is almost always used, so I further simplified. I copy this function up to this point. Then I will modify the function name, test container over variance, further simplified. Okay, I copy this function name once again, copied it, and pasted it here. I will disable it. Then at this point, I will remove this part. Okay, the function is the same up to this point. Then I can simply remove this part. Then I say items in my bag in order. Say I modified this title. Then I can say my bag, handle my bag items. For each, I provide the container my bag. Okay, I modified like this. Then I copy once again items in my bag, item by item in reverse order. Then you can say for each reverse. Please note that we provide the container, this is the container, and we visit each item in order, in reverse order. With this, we build once again CLS, hit enter, items in my bag, item by item, in order. So this is 10, 100, Python C++, C++ 17 standard. Items in my bag, item by item, in reverse order, C++ 17, modern C++ programming, 110 coins. It's in order, it's in reverse order. Okay? So this way of programming is much more efficient. If you want to know how this function is defined, right click, go to definition, then you can find overloads, define the handle, this is constant case, this is non-constant case, for each, this is for each reverse, So you can refer the source code. Now let's move on to container of tuples. Void test container of tuples. In the same manner, we define using age t, age is int, using weight, weight is double, using name, t, name is constant character pointer. Of course, we can use a CD string. Now we define people t using people t types. We can say vector of tuple or list of tuple, whatever. We will use list. Then say age t, weight t, name t. Okay? Then using person t, people t has member, tuple type. Okay? Now we declare people t, people, we can in place back or front. Now we provide age 18, weight 56.5 kilograms, name is Alice Kim. Okay, this is a tuple. The element is tuple. People in place back 676 kilograms. Name is Stephen Park. People in place back 45.7 kilograms. Name is Michelle Lee. So I entered the data arbitrarily. Now I can print out stream my friends. So people. So I print out my friends, or I say friends. Okay? Then I say friends. Now I call this function container of tuples. Now we start command prompt. We build once again CLS. So my friends 18, 56, Alice Kim 17, 70.6, Stephen Bach. So we listed my friends. If we want to access each element of friends, then we can say for or f or person friends. I say just f. Okay, then stream f and there stream each of my friends. Okay, stream and there. So we now want to access each friend's property like this. I copy once again, paste each property of my individual friend. Then I say or age, weight, name, app, stream. My name is name, stream. I am age, years old, stream. I weigh, weight, kilograms. So we can list and extract each properties of each friend, stream, and there. Now we build once again CLS. So each of my friend, we listed each friend, then we displayed each friend's property. I will give one more carriage return here. I will build once again CLS. So we can extract each property of each friend like this. My name is Alice Kim. Alice. I am 18 years old. I weigh 56.5 kilograms. My name is Stephen Bach. I am 17 years old. I weigh 70.6 kilograms. My name is Michelle Lee. I am 16 years old. I weigh 45.7 kilograms. So please understand how we define type and container. Then we insert elements. Then we can process all, and we can process each item, then properties of each item. Of course, these are most basics of how to use containers of tuple. Of course, you can change it to DQ or tuples too. Okay? It doesn't matter. I will provide more advanced technique how to use these container classes. I will post complete source code to my website, extension talkplayfun.com. By the time you watch this video, you can click this link and download complete source code. If you unzip the folder, then in CPP extension grep, you can find the complete source code in this folder. Please subscribe to my YouTube channel. Thank you for watching.